Hello everybody, I'm Morsi again. Let's begin the session that we can speak about satellites and launching them in the stationary geographic path or space path around the Earth.
It's very normal, by the way, for us to have their stationary path. So to say they are stationary, they are curved, they are fixed with respect to. The longitudinal position, in the position which is supposed to be the capital or a city, and the government responsible or linked to this project, or this satellite. Two main problems are present in propulsing satellite and spacecraft in general. The first is energy to get escaped from the gravity of Earth, and escape velocity. There's a difference. And the first thing is the force. The force needed in every time in the trip till it gets escaped from the Earth's gravity. Let's speak logically. What gets advertised in TV to get the rocket propelled, initiated horizontal to the Earth, this is illogic. This is illogical. It must be a takeoff, a normal takeoff, like a normal plane, and get with the most appropriate slope depending on air interaction, aerodynamics. It gets to a certain height where it becomes difficult for the engines to interact with the pressure of the atmosphere at these levels. For more than one factor, the pressure, the static pressure of the air in the above layers becomes very low. That is not sufficient to give the plane any enough interaction for the lift to make the plane get higher and higher, or apart and apart from the Earth's center of gravity. This can be easily solved. By the things. In the initiation of the trip, there was a problem, which was you cannot interact perpendicularly to the Earth's surface. But now it's possible. The force is lower. It's a approximate constant, no doubt. Approximate constant, yes. The height of the atmosphere of Earth is about 400 to 200 kilometers, which is less than 1/10 of the radius of the Earth. So it's approximately infinitesimal. So the force is approximately constant. But initially you did carry zero velocity for the aircraft, for the spacecraft, whatever it is to be called. So this was the problem. But there above, you can make it. You can make it. But there's another problem, that at the time you penetrate the velocity of sound, you will not be able to interact with air anymore, away from any known information that are being advertised all over the world from long time ago. Because you have succeeded the velocity that is governing the presence of the molecules of air, considering the matter, the substance of air, the substance of the air gas. You will not, when you interact with a molecule, you will not make it. You will not make it. So after this, and you will be controlling your aircraft with reactions, with bursting and exhausting, with space jets. So, since this is a problem in the atmosphere of air, you will have to lessen this as much as possible to get out of the atmosphere. And so, you will maintain your velocity just before the velocity of sound. To compensate attenuation in velocity, you will encounter the atmosphere at the higher levels. So first thing is, you'll be very near to the sound velocity before it. And this strengthens somewhat the weakness due to the lowness in the pressure of atmospheric pressure at this level, at that height. Second, you will be working at a higher rate of the engine. Third, you will be perpendicular, you will be in the direction of the radius of the Earth. You will be about from 6 to 8 times the force being used in lower levels. So by these two factors, or three factors of the actions, you would get overcoming this weakness, or this weak point in the trip of the space shift. After this point, approximately before the end of the atmosphere, the atmospheric ambience around the Earth, you will be preparing your second move, which is the thrust jets. By the previous, we have overcome the problem or the phenomena of force in every time in the trip, and the energy is somewhat overcome with a very important description of economicity in using the power and energy in the trip. Energy used in directing and getting the velocity of bodies in space, spacecrafts in space, is negligible to this, used and exerted, and intervenes in the atmospheric air. So this is the whole point. Jets are present, can be easily fabricated, no doubt. Get out of the atmospheric air of the atmosphere, turn off the engines, turn on the thrusters, and begin with your calculations. But take care, there is an angular inertia. You must be controlling this. So there must be just a thrust in one direction at a constant angular velocity, no, at constant, approximately zero angular velocity around the axis of the spacecraft. So you get the direction and direct yourself along this direction. This is the first step. The second step is you must be approaching the point, any point in the geostationary path of the satellite, and at the tangency, at the entrance, the point with the same velocity of flying of the satellite around the Earth, you will set it free with its direct direction at that point, and leave it alone and get your space and do whatever you want with it, either back or explode it. So it's now on its path, with its velocity, which is conservative, and you can, if a certain error or after the appearance or the occurrence of another error, you can adjust it by your internal dynamics and thermodynamics of the satellite. It was just an overview, just to help a project that is supposed to be set up between America and Egypt. My total love and respect, wishes and admire Allah's guidance till we meet Morsi.